Hi everyone, this is Ms. Desario, and this is our lesson 1.2. The objective for today is that students will be able to explain why psychology is considered a science and describe the advantages and disadvantages of correlational and descriptive methodology. So again, we're looking at this as a science, focusing on the advantages and disadvantages of each of the research methods.
So hindsight bias is the reason why we need research in psychology. Hindsight bias is this idea that after you learn the outcome, you would say, oh, I knew it all along. So let's say you had two relationships and then you shared these relationships with two different groups. So group A, and you say to them, out of sight, out of mind. And group A would say, yes, if you are separated in a relationship by distance, then that typically doesn't work out. But then you have a second group, you have group B, and you say, distance makes the heart grow fonder. And then they may say, yes, that's true. We know of people or this relationship that worked. Well, which one is it? We have both scenarios here. This is just an example, and I don't have the answer for you on this one, but this is why we do psychology research, is to figure out what that might be. So in psychology, we have to use the scientific method, and we start with a theory as our first step. And what we do is we come up with an idea. This example would be low self-esteem feeds depression. Well, we need to turn that into something that we can test. So we take that into a hypothesis. And our hypothesis is going to be a testable prediction. Once we have a testable prediction, then we can start to conduct our research. And we're going to do that by administering tests on both self-esteem and depression and determine if there was a low score on one means a high score on another. So you have a low score in self-esteem, you have a high score in depression. Once we have that data, we're either going to confirm, reject, or revise our study, and then we publish our results. One thing that is important to know whenever you're doing scientific research is that you have to be able to replicate it. Meaning somebody else has to be able to conduct it after you're finished, just to ensure that the data is accurate. This doesn't happen in every single point of research, but it is very important whenever you do research that you collect your data in a way that somebody could repeat your study. Descriptive research is one way that we can test our theories or our hypothesis. And this is information that cannot be obtained using the experimental method. Tomorrow, we're going to talk about the experimental method. Today, we're going to talk about other ways to get research. And we do this using a correlational studies. And you can think of correlational studies as things that you don't typically do in the lab. There are 3 examples of a correlational study. One is a survey, case study, and naturalistic observation. And we're going to go into more detail on each one of these. So first we're going to talk about what a correlation is, and then we'll talk about the 3 different examples. A correlation shows the relationship between 2 events. So in other words, does A prove B? Not cause, but prove B. Sorry, that's an R. One thing that is super important that you're going to need to know, and it's going to come up definitely on the AP exam, it does every single year, and that is correlation does not prove causation. It is not saying that one thing causes the other. It's just showing us that there's a relationship between those two things. And we look at the correlation in three ways: a negative correlation, a positive correlation, or no correlation. So no relationship means that one thing does not prove or show the other thing. There's nothing related. How hungry Miss Desario is not related to the weather. Those two things don't have a relationship. But what we can take a look at is two things that might potentially be related. And in this case, this is going to be a negative correlation. We know it's a negative correlation because it's a negative number in front, and our scatter plot is going downwards. So as one thing increases, something else decreases. So let's say sleep and tardy to school. The more sleep you get, the less often you are tardy to school. The less sleep you get, the more tardy you are. That makes sense, right? A perfect positive correlation. This is a positive number, it increases. Perfect means that it goes in a perfect straight line. So the increase of one thing leads to the increase in the other thing. So for example, in this case, it might be the more you study, the higher your grade. One leads to an increase of the other. Now, not every correlation is perfect. In some cases, you may see a couple things here and there, the scatter plot looks a little bit off. That's okay. That would still be considered a positive correlation as long as we see some type of a correlation there, some number, not just zero. So we all know that yes, you may study, but you still may get a bad grade here and there. It happens. So it may not be a perfect positive correlation. This here is just an example of a non-perfect correlation, but something that would still be considered a positive correlation. They did a study on height and temperament of men, meaning that the taller they were, the higher their temperament scores were. So this just shows you, but that's not always perfect, right? We don't see a perfect line, but we see a general skew in that direction. So we would consider this a positive correlation. These are examples of correlations, but showing you that correlation does not mean causation. So things may be correlated, but doesn't necessarily cause the other. So for example here, somebody may have low self-esteem. Yes, that could cause depression. However, depression could also cause low self-esteem. Another instance or another situation could be maybe there was a distressing event, maybe something bad happened, or maybe you are biologically predisposed to depression or low self-esteem. Maybe it runs in your family. So that could cause low self-esteem and depression. So just because two things are related does not necessarily mean one thing causes the other. Now, one variable that to take into consideration is in some cases we do have what's known as an illusory correlation. And that means that there is a non-existent correlation. A student of mine found a really cool website last year on this, but it's when two things seem to be related but have no relationship whatsoever. One example is drowning in ice cream, that we see an increase in ice cream sales and an increase in drowning. Well, do you drown because you eat ice cream? No, those two things aren't related. What is related is that most people buy ice cream when it's hot outside, and you're probably swimming when it's hot outside. So there is the relationship there, but we know that ice cream doesn't cause people to drown. Another aspect of correlation is a regression towards the mean. And what this means is sometimes we might see an extreme or unusual score or event happen. You may do really poorly on a test. Maybe overall you are a B student on every test, you score Bs, and you just, for whatever reason, you studied, but it just didn't happen and you did really poorly on one exam. That happens, but what we tend to see is that after that unusual event, you will fall back into your average. Another example for this would be like the weather, right? We may have a really hot day or a really cold day randomly, but then we tend to go back towards our average. So one way to study correlations is a case study. And a case study is when you are going to observe observe one or a small group in depth. So you're going to study them for a long period of time or in great detail. One positive to this is that it will suggest further study. Sorry, I should say pro. One con to this is that it could be atypical, meaning not normal. An example of a case study in psychology is over here to our right. This is Phineas Gage. And Phineas Gage had a metal rod, this metal rod, in fact, shoot through his face and come out through his frontal. So you can see this is his actual skull here. They kept his skull, and this is a computerized image of what happened to him. The metal rod shot through his head. He walked away from that accident, but it changed his personality dramatically because it completely destroyed his frontal lobe of his brain, which is this part of your brain right here. So people studied him in great detail, which was neat because we got a lot of information about the frontal lobe, but it was also slightly atypical because not very many people are going to shoot a rod through their entire frontal lobe in this fashion. However, people do get frontal lobe damage, and so we're able to use this information to understand the frontal lobe a little bit better. Here we have an example of a survey. A survey is self-reported attitude or behavior. So you get to decide, are we blah, are we happy, are we sad? Makes sense. The pro or the positive of this is that you can look at a lot of cases at once. However, a con or a negative to this is going to be the questions and sample. So in other words, word effects. How did you word your question? That can impact the way people may answer. In our example, there's just pictures, but most surveys don't just have pictures in them. So how do you word it? How do you ask people the question? And then also the sample. Who? This is going to be the who are you surveying? Is it a good population? In other words, are you surveying a lot of people, or are you only surveying a small amount of people? Are you choosing them randomly out of a hat, or are you choosing them specifically? Is it representative of the group that you want to study? So if I'm studying TC high school students, then I may need to make sure that I choose 10 freshmen, 10 sophomores, 10 juniors, 10 seniors, and then make sure that it represents the amount of females and males that I have, or represents the socioeconomic status, the ethnicities, and ensure that I have a representative sample. The final descriptive research method is naturalistic observation. And this is where you are going to observe behaviors in naturally occurring situations. The positive of this, or the pro, is that it describes behavior. I'm describing what I see. The con is that it doesn't explain it. So what we have here in our picture is we see an individual or a researcher studying animal behavior. So we can say what we see happening, but we can't explain why they may be doing this or why this is happening. Another thing to be aware of is what we call the Hawthorne effect. And what that says is that you improve your behavior or change your behavior because you know you're being observed. So if you know that somebody's watching you, you may not act in the same manner. And there are 3 ways that we can conduct any of this research. The first way is longitudinal design, and this means that we're going to study a group of people over their lifetime. And you can do this by naturalistic study, survey. That could all be done in longitudinal design. Cross-sectional means that you're going to compare several groups. To one another. Based on a similar variable. So it might be age, it might be gender, could be socioeconomic status. And then cohort effects is just a side effect of either longitudinal or cross-sectional design. And that just says that there could be some sort of influence happening of being part of a group. So today we discussed the different types of research methods, focusing on correlation, ensuring that correlation does not mean causation. It's just showing us is there some sort of a relationship between these two things. And we can do that by conducting a survey, doing a naturalistic observation, as well as taking a look at a case study or taking a look at somebody in depth. And we can do these in 2 ways, either a longitudinal study where we take a look at these people over a set period of time or a longer period of time, or a cross-sectional study where we take a look at a shorter period of time and look at groups of people and compare groups of people based off of a similar variable such as age or gender or socioeconomic status.